Forcemeters, I hope you had a wonderful weekend. Today we will continue our unit on forces and movement, and specifically we will learn about what's called force meters.
Let's smile together. Bismillahirrahmanirrahim.
Let's briefly review on what we learned last time. Last class, we learned that there are different sizes of forces. Forces can be big or forces can be small. And when an object is heavy, you will need to apply a bigger force to push or pull. On the other hand, when an object is small, you will need to apply a small force in order to push or pull. Here are some new vocabs that you'll be learning today. Number 1, it's called force meter, and number 2, it's called Newton. Force meter and Newton. Let's imagine. Over here, we have Aleski and Peng, who decided to have a foam fight to decide who is stronger. They both push on a piece of foam. Who do you think is stronger? How would you be able to tell who's stronger, Aleski or Peng? Let's think about it for a couple of seconds and we'll take it up together. Using a foam allows us to see how hard Aleski and Peng are pushing. The more squished the foam is, the harder they're pushing the foam. If Peng is pushing harder than Aleski might back up because of a stronger force that Peng is applying. If Aleski is pushing harder than Peng might back up because of a stronger force that Aleski is applying. If they are not moving at all and are staying in the same position, it means that they are applying the same force and the forces are balanced. In our example, we can't really measure the exact amount of how big or small the force that Aleski and Peng are pushing. However, there are other ways to measure how big or small forces are, and that is by using a force meter. A force meter is a piece of equipment that looks like this, and it measures how big or small the force is. Force meters measure the size of pulls. As you can see on the image here, force meter has 3 parts. It's got a scale reading where you're able to see how much force is being pulled, and it also has a spring and some weight attached at the bottom. In this example, apple is used as our weight, and we are measuring how much force an apple is pulling using a force meter. And we measure the unit of force by what's called a Newton. Does this name sound familiar? Yes, you're probably right. This unit is named after the famous scientist named Isaac Newton that we learned about last class. He is a scientist that discovered the existence of gravity. He did a lot of work on forces, and therefore he used his name to decide what the unit of force can be. Here's how to use a force meter. As you can see in the image, we have a little nut at the top of the force meter. We have to make sure to turn the nut to check the force meter is set to 0. And then after, if you look at the bottom of the force meter, there's a little hook. And then we're going to put the objects on the force meter, and you will put your eye level with the pointer and read the scale. On the scale, a set of keys has 4 newtons of force that's pulling the force meter. So a set of keys might have the force of 4 newtons. So here's a brief summary of what we learned today. Forces must be balanced in order for an object to stay still. In our Aleski and Peng example, if they are not moving and they're staying in the same position, the forces that they're applying are the same. Number 2, we use an equipment called the force meter to measure a force. And number 3, the unit of force is called the Newton, and please mind that it's a capital N, and that's named after a famous scientist named Isaac Newton.
Say hamdalah together. Alhamdulillahi Rabbil Alamin. The last I say, wassalamualaikum warahmatullahi wabarakatuh.